Hi everyone! Today we're going to be talking about solving multi-step equations. So the last lesson was about solving two-step equations, and we are still in that same boat, still in the same mindset. We just have a few more steps, a few more things we need to do before we can get to the point where we can solve like we did in the last lesson. Alright, so our first method of solving these multi-step equations is by combining like terms. So just a refresher, like terms are terms with the same variable and the same exponent. Alright, so we have 3a and 10a. Are they like terms? So in other words, do they have the same variable and the same exponent? Yes. So those are like terms. What about 7x squared and x squared? Do they both have the same variable? X and x? Yes, they do. And do they have the same exponent? They have a 2 as an exponent and a 2 as an exponent. So they are like terms. And just another refresher from last time, if I don't have a coefficient here in front of this, it's always just going to be an understood 1. Alright, now here is another example. Do these two have the same variable and same exponent? So I have 5y and 9y squared. Do they have the same variable? Yes, they both have y's. Do they have the same exponent? I have a y and a y squared. Now remember, if I have a variable with no exponent, what is that understood exponent? That's just a 1, right? So if I have y to the first power and y to the second power, are they the same exponent? No. So are 5y and 9y squared like terms? No, they're not. What about 8 and 3? Do they have the same variable? Well, they don't have a variable. So we can assume, since they're just numbers without a variable, they are also like terms. Alright, so now that when we understand what like terms are, let's talk about combining some like terms. So if I have 8a and 5a, they are the same variable, right, a, and the same exponent. So they both have an exponent, an understood exponent of 1. And most of the problems, actually I believe all the problems that we do, will just have a variable without an exponent. Alright, so 8a minus 5a. How would I combine those? Well, I just leave the variables the same and I combine the coefficients, right? So 8a minus 5a is going to give me 3a because 8 minus 5 is 3 and my a stay the same. Okay? Same with this problem. So I have 5y plus y. Are they like terms? So they have the same variable? Yes. Same exponent? Yes. So 5y plus y is going to give me 6y. Because remember, just because there's no number here doesn't mean you don't have to add it. There's always an imaginary 1 there with the y, okay? And here we have 2x plus 4 plus 3x. So what are my like terms in this problem? I have a 2x, I have a 4, and I have a 3x. So first let's look at any term with an x in it. I have 2x here. Does 4 have an x with it? No. Does 3 have an x with it? Yes. And they both have the same exponent too, right? So they have the same variable and the same exponent. Alright, now, do I have any other terms with no exponent here? No, so this one's just going to be by itself. So I can combine these two terms because they have the same variable. So 2x plus 3x, I'll just rewrite it like that. 2x plus 3x, and then what am I left with? Plus 4. So 2x plus 3x is going to give me 5x, and all I'm left with here is plus 4. Can I combine these two? No, I can't, because 4 does not have a variable of x with it. So when we combine like terms, we only combine the terms that have the same variable. All right, so let's talk about solving equations with like terms in them. So in our first example, we have m plus 2m plus, or m plus 2m minus 4 equals 14. All right, so our first step before we do anything is going to be combining like terms. This is going to make it so much easier in the long run, because ultimately we're solving for m, right? Whatever our variable is in the equation. And since we have 2 of them, that might get confusing. So we can actually combine those like terms. So I have an m, I have 2m. Do I have any other terms with an m? No, I don't. All right, so I can combine those two terms, right? So m plus 2m is going to give me 3m, right? Because this is like an imaginary one. So I'm left with minus 4 on this side, and then I have equals 14. Now I'm back to that solving two-step equations mindset, right? So first I'm getting rid of the attached addition or subtraction. So anything attached by addition or subtraction to the variable. What is attached here hanging on by addition or subtraction? It's this 4, right? So I'm going to add 4. I'm going to do the opposite of what it already has given me. So, and whatever I do to one side, I have to do on the other side of the equal sign. Those will cancel because minus 4 plus 4 is 0. So I'm left with 3m on this side, and 14 plus 4 is 18 on this side. Now, I'm going to solve by multiplication or division. So first I need to check, what is this operation here, 3m? Well, that must be being multiplied, right? 3 times m gives me 3m. So what's the opposite of multiplication? Division. And I'm going to be dividing by 3 because that's the number connected to the variable here. All right, so whatever I do to one side, remember, I also have to do on the other side. All right, so 3 divided by 3 is just going to give me 1. And I know that 1 times anything is still just itself. It's not going to change the value. So 1m, or just m, equals 18 divided by 3 gives me 6. All right, and in our last video where we were solving these equations, you could plug this back in and check it. You could either plug this 6 in up here, or you could plug the 6 in to this equation where it's simplified, so you only have one m term, whichever one you choose. All right, let's try another example. Remember, we're first combining like terms. So what are my like terms here? Well, I have a 4x, I have 10, and 6x all on this one side, and on this side I have a 30. So I need to think, do I have anything else in common with this 4x? So are there any other terms with an x in them? Yes, I have the 6x here. All right, now can I combine this 10 with anything over here? I can't. So I'm going to go ahead and combine 4x and 6x. I'm going to combine them. So 4x plus 6x, because this sign here is positive, right? So 4x plus 6x is going to give me 10x. Okay? Now I'm also left with this term here, right? Plus 10. Don't leave this term out. Don't forget about that one. All right, equals 30. Now I can solve like I'm solving a two-step equation. So I have, I'm going to get rid of anything attached to the variable by addition or subtraction. So it's almost like doing the opposite of regular order of operations. You're kind of going backwards a little bit. So I'm going to subtract this 10 from both sides. And 10 minus 10 is 0. So I have 10x left on this side equals, what's 30 minus 10? That is 20. Now, I check what operation is being done here. Well, I have 10 times x equals 20, right? So what's the opposite of multiplication? It's division. So I'm going to divide by 10 on both sides, because whatever I do to one side, I have to do the other. Alright, so 10 divided by 10 is 1. I'm left with x equals, what's 20 divided by 10? That's just 2. So x equals 2. And like I said before, if you want to plug this back into the equation, you can plug it in here, or you can plug it in here. Alright, it will work in either one. Okay, let's try another one. And don't forget those steps up here, alright? So we have 5y plus 3 plus 3y equals 27. So let's look for any like terms. Do we have any more terms with a y in them? Yes. I have this 3y here, right? They have the same variable, so they are like terms. Alright, and do I have anything over here to connect this 3 with? Not on this side, so I'll just leave that as it is. Alright, so I have 5y plus 3y. So 5y plus 3y, because it's positive here. What's 5y plus 3y? That's going to give me 8y. Now remember, when we're adding these like terms, it doesn't affect this variable here. So it's not going to become y squared or anything. We're just adding. So 5y plus 3y equals 8y. I'm only going to combine the coefficients, okay? What am I left with on this left side? Well, I didn't write the plus 3 yet, so that's what I have left on this side. Equals 27. Now, my next step is to get rid of anything attached to the variable by addition or subtraction. So I'm trying to get y by itself. I need to kick off this 3 here. So opposite of addition is subtraction. So I have 8y equals 27 minus 3 is 24. Alright, now I need to check what operation is being done here. 8 times y would give me 8y. So these two are being multiplied, right? So how do I undo multiplication? I simply divide. And remember, I'm dividing by 8 because that's the number attached to y here. That's what I want to get rid of. That's the only way I can get rid of that 8 there. So I'm going to cancel those, right? Because 8 divided by 8 is just 1. And if I put 1y or y, it doesn't matter. They're the same thing. So y is all I'm left with on this side equals 24 divided by 8. That's going to give me y equals 3. Alright, and let's go ahead and plug in. I'll just show you how I can do either one. So if I wanted to plug into this one here, I would have 5 times 3 plus 3 plus 3 times 3 equals 27. Alright, so I'm just plugging in 3 for all the y's in this first one. So I get 15 plus 3 plus 9 equals 27. So 15 plus 3 is 18. 18 plus 9 is 27. 27 equals 27. So that one checks out. Let me show you what I mean that you could do it either way. If I were to plug in 3 into this equation, I would have 8 times 3 plus 3 equals 27. So I'd have 24 plus 3 equals 27. 27 equals 27. So either one I want to plug those into, it will work because they were like terms, remember? Alright, so remember your steps. You need to combine like terms, so any terms with the same variable and exponent, and then get rid of the attached addition or subtraction, and then solve by multiplication or division.